So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as data input methods in GIS. So what is data input and what type of data we are going to use in GIS for further processing. So if you remember, we have already discussed in the previous lectures that we are using two types of data in GIS. So one type is spatial data, the other type is non-spatial data. So spatial data is, if you remember, we have discussed like spatial data is the data which you can see around you, all types of satellite data, all types of topo maps or topo sheet maps, all types of aerial photographs, or any data which you click through your camera, or any data which is given through a digital information, that all comes under spatial. And non-spatial information is like the information which is attached to the spatial is called as non-spatial. So this we have already discussed. Now, what are the different methods how we can just input the data in the software? So the software which we are using, how we can input that type of data. So we have different methods here that we are going to discuss today. So let us start with our contents. Our contents will be like data input methods, types of data input methods, keyboard entry, manual digitizing, scanning, and automated digitizing. So these are the different methods how we are going to input the data, and we are going to discuss right now. So let us start with the first slide. So we have here data input methods. So there is a data input methods means how can you insert the data. For example, you have a paper map. You have a paper map here. So what is a paper map? In the form of paper, we can call it as an analog data. If you want to work with that paper map, we have to input that data first into GIS. So what is the procedure? How can we input that data? That we are going to explain here or discuss here. So there is a distinction between analog and digital sources of spatial data. So there are two types of spatial data. One is analog and one is digital. Okay, two types of data we have. Both the data can be used in GIS for further processing. So first of all, if you want to use analog data, we have to convert it into digital format, or else if you don't have analog data, if you have a digital data directly, that can be used in GIS directly. So both can be used in GIS. So analog data are normally a paper form. So they are a paper form and include paper maps, tables of statistics, hard copy, aerial photographs. These all includes in analog map or analog kind of data. So if you have tables, if you have charts, if you have statistics in the form of a paper, that becomes as a analog data. But still, if you want to use it in GIS, still if you want to work with that all kind of data, we have to input that data in the GIS process first. So all these forms of data need to be converted to a digital form before use in the GIS software. Okay. So digital data like remote sensing data, these are already in the compute readable formats. Like from remote sensing, the satellite data which we receive, so that all data, it is already in the digital format, that can be easily directly, it can be converted to a digital form directly. We can work with that kind of data because it is already in the digital format and are supplied on a diskette or magnetic tapes or CD-ROM or across a computer network. So we can just use that kind of data and we can just directly we can work with that digital data because it is in a computer readable format. So why do we need to convert the analog data to digital data is to make it to computer readable format. So once the paper map is converted to computer readable format, then easily we can work with that kind of data. Otherwise, analog data we cannot work with GIS. So all data in analog form needs to be converted to digital form before they can be inputted GIS. So here we can see one image here. So this is the image which is conceptual view of data stream in GIS. So what type of data we use it, from where we receive it, what is the different source we can just use in GIS and we can input in GIS. So first one, what you can see here is maps. So maps, you can use it if it is available. It will be available in the form of paper map. Okay, paper format. So this paper format can be first digitized. How we can digitize? Through scanning or through capture of the data. Next, you can see here you have a satellite data. Satellite data is already in the digital format. If not, if it is in a paper format, we can use it through scanning. And next, you have a digital data, you have a tabular data. So if the digital data is available, tabular data is available, you can just transfer the data through data transfer. Or if any ideas we have, any ideas or any key coding ideas are there, that soft ideas can be simply implemented through the keyboard entry. So directly we can just type through the keyboard and we can enter the information to GIS. Then data capture, editing, cleaning, reprojection, regeneralization, edge matching and rubber sheeting, layering, and then integrated GIS database we can prepare. Now here we can see data types and their sources. We can see here in this table we have different data types and sources. Data type means what kind of data we use in GIS, and what are the different sources what we receive this data from GIS. So if you talk about topography, if you want to convert the information like topography, so this topography if you want to use, we can just receive this information. In topography, we have digital elevation model, digital terrain data. So this information, if you want to receive, we can just visit this GSI, NATMO or SOI. Now, what is GSI? GSI is Geological Survey of India. NATMO is National Atlas Thematic Mapping Organization. And what is SOI? SOI is Survey of India. So these are the different, we can say, organizations where we can you can receive the information. This is the source from where you can get the data. So like that, if you want land use, land cover, ownership and political boundaries and transportation information, if you want, we can just find out through this source. What are the source here? SOI. So land use, land cover information through SOI is Survey of India, or through land records, or through R&D or APSRTC or TSSRTC, whatever it may be, any state data. If you want to get the information, you can get through these sources. Now, hydrography. Hydrography is the information you can get through Ministry of Water Resource, State and Central Ground of Water Board, and socioeconomic and demographic data, census, tract boundaries, demographic data. This all information you can get from Department of Census, Bureau of Economics and Statistics. Soil information you can get from NATMO. So what is NATMO here? NATMO is National Atlas Thematic Mapping Organization. Okay, and if you want any remotely sensed data information, you can get through the National Remote Sensing Agency here, but actually it is center now, Remote Sensing Center. So now we can receive it from NRSC, that is National Remote Sensing Center. Okay, so if you want to get any remote sensing data, we can receive from NRSC. So these are the different sources and these are the data types which we can use it in the GIS processing. Now, types of data input methods. So what are the different types of data input methods? What kind of methods we can use to input the data? So here we can see here we have keyboard entry, manual digitizing, automatic digitization and scanning. So these all are different types of input methods, how we can just input the data in GIS process. Okay, so digital data must be downloaded from their source. So just now you have seen in the previous slide what are the different sources. So if the data is available online, if the data is in digital format, we can directly download from the source, and later and media, and may require reformatting to convert them to the appropriate format for GIS being used. So reformatting or conversion may also be required after analog data have been converted to digital form. For example, after scanning a paper map, the file produced by the scanning equipment may not be compatible with GIS, so it needs reformatting. For example, if you want to scan a paper map, so this is the paper map. If the paper map is scanned, then the scanned map will be maybe converted to .png. So if this PNG format will not work with GIS, we have to convert. Suppose JPG we have JPEG format. So in GIS we can use image format .img. So we have to convert it into .img to use in GIS. So if it is not converted, if it is not compatible with GIS, we need to reformat the data. We need to rescan the data, and further we have to save the data in the compatible format. For both the analog and digital data, keyboard entry method, manual digitizing, automatic digitizing, and scanning methods are very important, and these are given in detail below. We can see. So first we will let us see what is keyboard entry. So keyboard entry often refers to a key coding. So keyboard entry, like if you remember components of GIS, of GIS. So what are the components of GIS? If in a component we have hardware, software, software, people, user, okay, network. So this all comes under the component of GIS. So out of this, if when you talk about hardware, so in a hardware you have one component as keyboard. So where it is used, so keyboard can be used wherever the key coding is required. Key coding in sense when you want to add or you want to input any non-spatial data. If you want to add any non-spatial data, then we have to take this keyboard entry. So this is the method for entry of non-spatial data. So if you want any key coding, any georeferencing data to be added, any information which is in the tabular format to be added, the keyboard is used for entering the data. So this technique is used for the attribute data. So as I told you, attribute data is non-spatial data. Okay, non-spatial data. So what is non-spatial data? Non-spatial data is also known as the attribute data. So attribute data, the information about the spatial data is called as the attribute data or non-spatial data that are available only on paper. So this technique can be mixed with digitizing process for the creation of GIS database. So this coordinates of spatial entities database. The coordinates of spatial entities like point, line, area, features can be encoded by the keyboard entry. For example, here what we are trying to say is coordinates of spatial entity. So if you remember, we have three types of shape files. Okay, shape files, or we call it as vector data, or we call it as features. So these all, if we talk about shape files, if we talk about vector data, if we talk about features, these all are point, line, and polygon. Okay, point, line, and polygon. So this kind of information, if you want to add a non-spatial information to this point, line, and polygon, then we have to use the keyboard entry. So for example, you have kept a point here, so point becomes spatial. Now if you want to add any non-spatial information to it, what we are going to use? Non-spatial information we are going to use keyboard. So keyboard we are going to use in non-spatial information through keyboard entry. So this method is used when the coordinates of these spatial entities are known and there are not too many of them. So this is only used when the known coordinates are there. So what are the coordinate system here? So coordinates means we call it as latitude and longitude. So latitude and longitude is what? That is the location. So this location we are going to assign it with the help of the keyboard entry, and that too when there are too many of them are not there, because all the entries cannot be assigned. Too many entries cannot be assigned through keyboards. Only few of them, if it is available and if it is known, then only it is possible. So if the coordinates are more in number, this data can be encoded using digitizing. Okay, so the procedure of keyboard entry can be used to enter land record information. So any information related to the land use, land cover, or land parcel, that all information can be added through the keyboard entry. So this method leads to obtain a very high level of precision data by entering the actual surveying measurements. This method is used for the development of cadastral information system. So cadastral information system is what? So cadastral information is the information about the villages. Okay, villages which gives you the parcel information. Parcel information. So what is parcel? So parcel is a piece of land. We can say piece of land information if you want, that can be done through the keyboard entry, and piece of land information is given to through data input methods. Now manual digitizing. Manual digitizing is the most common method of encoding spatial features from paper maps. Now the second method where what we talk about is manual digitizing. So manually we have to digitize. Manually we have to digitize means there will be a paper map. There will be a paper map, and on the paper map, suppose this is the map. If you want to digitize this map, we have to do manually, and this map will be attached to a computer system. Okay, computer system. Now when you start digitizing, what we have to do is one by one we have to start drawing this map with the help of the cursor, so that we call it as manual digitizing. So manually, one by one, we are going to convert. We are not going to scan it. Manually, with the help of a tablet and with the help of a cursor, we are going to convert the entire analog information, spatial feature information to the digital format. So it is a process of converting the spatial features on a map into a digital format. Like point, line, and areas features that form a map are converted into XY coordinates. So this all information can be done through a digitizer. So for example, a point is represented by a single coordinate. So if you want, if suppose this is the map, this is the paper map. So this is the point here. So this point will be having a single coordinate, single latitude, and only X or Y, and a line or a string of coordinates. A line will be having a string of coordinates. So 1, 2, 3, 4, like string of coordinates. And when one or more lines are combined with a label point inside in an outline, then the area polygon is identified. So thus digitizing is the process of capturing the series of points. It is a process of capturing the series of points and lines, that is called as a digitization, or we have discussed in the previous lectures also that what is a digitization. So that we have seen in the software. Now here manual digitizing can be done in the software as well as through the tablet also, digitizing tablet also. So points are used for two different purposes: to represent point features or to identify the presence of a polygon. Manual digitizing requires a table digitizer that is linked to a computer workstation to achieve good results, and the following steps are necessary. So here, as I was telling you, we have a table digitizer, and that is attached to the computer workstation. From the computer workstation, this is how it looks like. This is the figure I'm talking it about. So you have a contemporary tablet using a grid of wires embedded in the tablet to generate a magnetic field is detected by the cursor. Now here you have this is the tablet here. So on the tablet you will be having a map. Okay, so this is the map. Now this map is connected to the computer system. Okay, computer system. Now from computer system, a cursor is attached here. So as this cursor is moved one by one like this, if I want to digitize this, so one by one the cursor will be moved here. So like this, there will be lot of vertex point we have to click. Okay, so this vertex point, as we complete till here, so this map will be created and generated in the computer system. Okay, generated in the computer system. So this is the process of the olden days, like when we were not having the software, then we were doing this kind of digitization process, manual digitization process. Now the facility is like we have the digital map directly, we can just input in the software and we can just start digitizing in the software itself. This is the old process. So digitizing operation, the map is affixed to a digitizing table. Three or more control points are to be identified and digitized for each map sheet. So that is fixed to the digitizing table as I showed you here. So this map is fixed to the digitizing table. Already this map is fixed from all the sides. So it is attached to the digitizing table, and as the cursor is moved, the map is generated in the computer system. Now, the points are called as reference points or ticks or control points. So, the coordinates of these control points will be known as the coordinate system to be used in the final data such as latitude and longitude. That's what I'm saying. So, as the points, wherever we fix the points, wherever we draw the points, so these all points is a reference points, and as many points we are going to move on through the cursor. So, these points will be fixing as a xy coordinate in the map, which can be used further for the further data can be used for the final information. The control points are used by the system to calculate the necessary mathematical transformations to convert all coordinates to the final system. Now, the more the control points, the better the accuracy of digitization. So, more the control points, for example, what I'm trying to say is, so this is your map. If more control points means one point you have kept here, one point is here, one point is here. So, as many curves you have kept around 10 to 15 points. So, if you want more accuracy, so you have to put more and more number of points. So, as many points we keep, the accuracy will be more. So, as many points we keep like this, for example 20 points, 30 points, so as many points, more accuracy, it will fit accurately to the location. Otherwise, if you are going to put less point, for example, suppose this is the map, so if I'm going to put a point here, put a point here, here, so 4 points I'm putting, then the accuracy will be very poor. So if I need more accuracy, I have to give more and more number of points. So digitizing the map contents can be done in two different modes: point mode and the stream mode. So point mode is one by one you have to keep the point like this. Stream mode is continuously you can just fix the location by assigning number of streamlines. Okay, so point mode is the mode in which the operator identifies the points to be captured explicitly by the pressing a button, and stream mode is the mode in which the points are captured at a set of time intervals. So most digitizing is currently done in the point mode only, because we have number of curves in the map. So if you want to cover this entire map with the curves, you have to use this point mode only. So point mode is used for a digitization process to get a more accurate information to the final output. Now, if you talk about the scanning and automatic digitizing, so what is scanning and automatic digitizing? This is the most common method we use for the automatic digitizing process. So, what is the most common method? For example, you have a paper map. Okay, this is your paper map. So, this paper map, if you want to, and it is also known as analog map. Okay, so there's this data. If you want to use in GIS, what we are going to do, we use scanner. Okay, scanner is one of the hardware component. So hardware component, this component we are using, and through scanning we are converting the analog information to digital data. Okay, so this is scanning and automatic digitizing. That means, so once we scan the data, it is automatically it is converted into digital form. Now it is digital, all the data one by one, each point of the paper is converted to the digital format. So that format is called as scanning. And also we say it as automatic digitizing. Automatic digitizing means automatically it is converting the analog information to a digital information. That becomes the automatic digitizing. Now, scanning is an appropriate method of data encoding when raster data are required, since this is the automatic output format for most scanning software. The scanning may be used as a background raster datasets for the overplotting of vector infrastructure data such as pipelines and cable. So, scanning can be used as a background of raster datasets. What is a raster dataset? So this, if you remember in the previous lectures when we were learning about the digitizing in GIS, so digitizing in GIS, what we are going to use, the input data is always, input data is what? Always it is a raster. Okay, so input data is raster data. So how we get the raster data? So we get the raster data through scanning. So this through scanning or direct direct digital data we get through this process, like satellite images, aerial photographs and all. So this data, once it is scanned, so it can be used as an input file. Background raster is input file, because once you want to convert raster to vector, you want to convert raster to vector. So what we are going to do in raster to vector, in raster, suppose this is the image information, this is the image information. So this information we are going to convert it into vector. So if you want to convert this vector, what we have to do, this raster we have to use it as a background raster. Okay, so background will be the raster, and then over that we can just, that's what it's written here, for over plotting of vector infrastructure data such as pipelines and cables. So if I want to convert the raster data to vector, so what I have to do is I have to use the raster data as the background. On that background, whatever information is there, that information I can just one by one, step by step, by using point, by using line or polygon, I can just convert it into a vector information. So such as pipeline and cables, pipelines and cables, what if I want to convert pipeline and cable, then what I have to use, I have to use a line, I have to use a line feature. So this line feature I will be using, and I will be converting it to the vector. Okay, so a scanner is a piece of hardware for converting an analog source document to a digital raster format. There are two types of scanners. So if you want to scan the data directly to the digital format, there are two types of scanners. So one is flatbed scanner and one is rotating drum scanner. So what is flatbed scanner? Flatbed scanner is the scanner. This is A4 size map. A4 size map. We can scan. A4 size map can be scanned. A4 size map can be scanned, and we can see it is the cheapest one, and it is used in offices. So in offices you can use this A4 size map, can be scanned easily, and is the cheapest one, and you can use in the offices. The cheapest scanners are the small flatbed scanner, and high quality and large format scanners are rotating drum scanners, in which the sensor moves along the axis of rotation. So what is flatbed scanner and what is rotating drum scanner? So flatbed scanner, as I told you, it is the A4 size map scanner. If you have a A4 size map, directly we can just put in the scanner and we can just scan this map. These are used in the offices. Okay, so this is your flatbed scanner. Like normally you can just put in the map here and just scan and come out with a, then a digital image of a map is produced by moving an electronic detector across the map surface. The size of map area viewed by the detector and the scanning should be processed or edited to improve the quality and convert the raster to vector after the online digitization. So this automatic digitizing, or we can say digitizing process, is for converting the, or the background of raster is used for the converting the raster to vector. Okay, like whatever digitization we do. So the accuracy of scanned output data depends on the quality of the scanner, the quality of the software used to process the scanned data, and the quality of source document. So this is like quality of software used to process the scanned data is, how can we get the accurate information? If you want the accuracy of the scanned output, depends on the quality of the scanner. So if you have a proper higher pixel scanner, then the quality of the scanning will be more better. If you have low quality scanner, the quality of the picture will be very low, the pixel size will be very low, and the quality of software used to process the scan data, and the quality of source document. A very important feature that a GIS user should observe after scanning the paper map is occurrence of spillines, which is black appearance on the scanned output. Okay, so this can be removed by using the process called as thinning. We can use the lines through thinning process, and the resolution of the scanner used, you can see while scanning, there will be, after scanning and printing, you can see very slight lines like this, it is appeared on that. So that means the scanner will go like this and it will scan the entire document, so that later these lines can be reduced it or removed it by using the thinning process. And the resolution of the scanner used affects the quality and quantity of the output data. The cheaper flatbed scanners have resolutions of 200 to 500 whereas the more expensive drum used resolution of 10 to 50 So, like rotating drum scanner is the scanner here. We have not yet discussed. Rotating drum scanner is the scanner which is having like this will be like a big scanner with a drum here. Okay, and this is suppose A0 size map which is kept in the this scanner. Okay, rotating drum scanner, okay, kept in the system. And as this enters inside this drum, so it keeps on scans like this, and further you can get this information which is attached to the computer system. You can just see this information in the, suppose this is the map here on this A0 size, it will be appeared on the computer system like this. So with a high resolution, if you have good resolution, you will be getting a high resolution map. If you have low resolution, you will be getting a low resolution map. So cheaper flatbed scanner will be having 2 to 500 whereas the more expensive drum scanners use a resolution of 10 to 50 So if it is having good resolution with the number of pixels more, so resolution, if you remember resolution in terms of pixels again, so pixels in sense high resolution means it will be the scanning image will be having more number of pixels. Okay, number of pixels will be more here. So this will be the higher image, we can say this is the high resolution scanner. Whereas if you have a pixel like this, if you have a less number of pixels like this is low resolution low resolution scanner. Okay, like normal cell phones, when we use with the pixel, if you have a low resolution camera, you will be having very low quality picture. So if you have a high resolution camera, more number of pixels if you have, then the quality of the picture will be very high. So this is how the resolution of the image will be decided based on the quality of the scanning system or scanning uh, process, or we can say that scanners which we are going to use, flatbed or the rotating drum. So these are the hardwares which can be connected to the computer system, and this is the process how we input the data. So, in today's lecture, we have discussed about what are the data types, what are the different data from different sources we use the data. And if you want to work with GIS, we have to input this all data into GIS. So, to input this all data into GIS, there is only one process. There are three methods, and there is only one process that the data should be in the digital format. Once the data is not in the digital format, we cannot use this data in GIS. To convert this data to the digital format, the data should be converted into the raster format. So how the raster format can be converted? How can we input the data? We have three types of input methods. If you want to input the non-spatial information and the attribute information, then we have to use the keyboard entry. Through keyboard entry, we can use the different types of data to enter the attribute and the non-spatial information to it. Then there we can use a keyboard entry. And if you want to do a manual digitizing, means if you want to convert the analog information to the digital information, manually we have to digitize one by one through assigning the points or the coordinates. So as many coordinates we assign, the accuracy will be more. As much less coordinates we assign, the accuracy will be less. So this is how we can just convert the whole information. Or else if these two we exclude it, then we have to go with the automatic digitizing process, that is scanning. So directly if you click a picture, that is converted to the digital format. If you click a picture through a camera, through a cell phone, through any kind of device which can capture the image, that all information can be captured and be converted into a digital format. So these are the different methods. I hope you understood how we can input the data in the GIS process. So these are few references which you can go through and find out about the more content. So references, majorly you can just go through this Eventuality book, which is a very good book for referring about remote sensing basic. If somebody is new to this remote sensing topics or the subject, they can just refer to this book to get more information. And you can just go and refer the fourth edition of this book for getting the more information about the contents. And you can just go through this link for the further more information. And for GS, this is also a very good book like Tank Chime, which is from the TMH Publication and Corporation. So that's all for today. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.